Hello and welcome back to another video. And today we'll be reviewing calculators. And sort of a comparison on the evolution of them. Now this one is trekking on to I don't know, about 6 years now. It's well worn and still works, but the 6 key has troubles and stuff. So this is a nice replacement. I'll still keep this, of course, but you know. So something interesting about these is because of the nature of capitalism and its infinite growth, they've cheaped out. So interestingly, so I think this is a newer version. I mean, they're from different brands, but they're functionally identical. There's no removable battery cover on this. You have to take the whole back off. And it's just the plastic on this one just feels better. I don't know about it. This feels tougher. I really don't know. And I also have wrote some useful equations and stuff on here for electronics and stuff. Also, the manual. The manual is also nice. Yeah. Sentry also makes a 4-function calculator and a graphing calculator. Both of which are just your standard generic calculators that many brands slap their name on. So let's compare the. This has a guide. Where the hell did that come from? Now, personally, I love these things a lot. They're cheap. This one was $1 from Dollar Tree, and this one is $3.25 from I don't know. Oh yeah, Five Below. But they're great value for money, and I think I'm going to. Yeah, now you can see that better. The battery in this is it's very used. In fact, it has some damage on the IC. Displaying regarding the LCD drive and stuff. So they both probably use the same chip or a chip of the same function. I actually haven't taken this one apart before. I have looked into the battery. It takes 2 cells. This one is supposed to only take 1 cell and then boost up, but in order to fix that weird display problem that I caused, I removed its little boosting capacitor and just added a new another battery, and that made this work again. So something interesting about these is there's a version of these calculators that's even newer that have this weird issue where the on button is wired up differently, so you can't enter stat. You can on these ones. I hope you can see it. Yeah, you can see it. And it won't, and because it just resets it. So so if you like store something in the store something in the memory and then turn it off and back on, it'll forget everything. But anyway, so some interesting things on here is, in order to reduce cost, the chips, the chip in here has very little storage, because of course, when you add more storage to a chip, you need more transistors, and when you add more transistors, you increase the size of the die and the complexity. And when you do that, you increase the cost of creating the die. So these have quite a bit of interesting tricks up its sleeves for to get around that. So first, the stat. Now, on other calculators, you get a menu, or a list, basically. And you can, do stuff like that. You can, like, scroll up and down, stuff. But we're too luxurious for that. I really hope that didn't break. Although, the side cover did come off for some reason. So it's probably dead. Remember, if your shoes come off, you're dead. In fact, I'm dead right now because I have no shoes on. So it calculates the values for the stat on the fly when you actually add stuff on to the variables. In fact, the data sheet for the IC in here is very interesting. I'll link to them in the comments or something. So in this mode, in stat, well, not in stat, first off, the way this does, like, math expressions is, basically has a stack with 4 values in it. It's probably slightly more complex than that, but you get the idea. You can, so if we do, actually, notepad time, like Big Clive, except shit. So it has basically a 4-level stack, except instead of being RPN based, it's algebraic based. Although I would absolutely fucking love if they would release a version of the chip that's RPN. That would be beautiful. So, in fact, on the die, so you have this stack on these, and the camera isn't focused. That's just fucking great. That still doesn't look focused. If I... Okay. So you have your stack. Weird stack thing. And it has 4 values. In fact, on the die, you can actually see 4 distinct rectangles, basically. On the die itself. And then, of course, you have the pads that go off onto, etc. and it probably also has some and the registers. So you basically have these 4 registers on the chip that store things. So in this mode, actually, I'm gonna turn the other one off. So in this mode, these also probably store things like how many like parentheses and stuff, and like the operators, because it's an algebraic notation calculator. So if we do, let's do a test. 6 plus parenthesis. Let's type that in. See how many times we can type that in. 6 plus parenthesis. The parentheses thing shows up. 1. 2. 3. 4. And there we go. I wonder if there's actually like, does he use the display register as a thing? I don't know. It also has a swap button to swap the 2 registers, which is probably some sort of like flip-flop or something that like switches swaps and enable lines on the 2 registers. I don't know. It most certainly doesn't actually swap the contents. That would be ridiculous. Ridiculously complex. Kind of like in Z80. So in this mode, so in this mode, what the hell am I gonna say? Well, another thing is, something interesting with the parentheses is, let's clear this. Let's just record how many times we can press the left parentheses. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 15 times. In fact, you can take this and add parentheses to it, and then, dude, I think, yes, 60 total parentheses. Why is that thing? Whatever. So in this mode, all the whole stack is available for like expressions, including in like the other base notations. You can actually 2, 3, 4, 5. But in stat, of course, we need somewhere to put the values for like our variables. So how many? I'm gonna swap to this one because you can actually see the. No, they're actually both hard to see on camera. This one's actually easier to see in the real with the actual eye, because this is red and this is blue. It's weird. So on here, of course, we need a place to store our data for like how many times we've added values, the sum, and you know, stuff like that. I think it calculates some of the other values on the fly. Yeah, it actually does. For the way it calculates these other values is that it only keeps track of a couple of values. In fact, let me go get another phone so I can look this shit up. So, jump cut. I'm back. Well, anyway, there are like two companies that make the chip for these things, Integral and Cylane. Cylane, I'm pretty sure is a company from like Taiwan, so the Republic of China, and Integral is from somewhere in Eastern Europe. And something weird is you have two entries on alldatasheet.com. One that ends with a C and one that ends with an M. I cannot see any difference between the two data sheets. I don't know what is. If we take a look on him and we zoom in on the iPhone and move the droid, you can actually see 4 distinct rectangles. In fact, each of them is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So, zoom out. So, 13 times some sort of bit width times 4. So, yeah, that's very interesting, isn't it? And you see, I was correct. It would be awesome if one of these would sell this chip in like a proper package, so that people can use it in their stupid projects. What is the stats? There's our that. It is a very interesting read. Genuinely is. Okay, here's the section about the random number generator. Focus. The position first pressed has preference, and no input is made to data set in the exponents section. When pressed as the first set number, it is regarded as 0, and dot keys are pressed. Random as a second F, so you have to do it through pressing the second F button. Pressing this key shall display the random numbers. The range of random numbers is 0.000 through 0.999. And I think the way it works is it basically in the background it just counts this, and when you bring it up, it just reads from this. Seems like I don't know. Yeah. Let's take a look at the coordinate conversion in the meantime, as we're on the yellow brick road onto stats. Wow, that would be a really weird and really shitty Wizard of Oz version. Mainly the shitty part. Coordinate conversion, A, B, R, X, Y. These keys convert the rectangular coordinates into the polar coordinates into the rectangular coordinates, blah, blah, blah. The angles units that have been set by the DRG key follows. So, you might be thinking, what the hell is it talking about? These keys, A and B. They also have another function, which is calculate imaginary numbers, but in the regular mode, they can be used to convert things. I mean, coordinates, not just anything. Although it would be awesome if it could convert from WAV to MP3, so that you wouldn't have to buy random Windows programs. What the hell is it with Windows and fucking hell, what a tangent. Dust on screen. No, thank you. So let's well, first off, let's get the calculator. And compare between it. So of course on here you just do shift polar 1, shift colon 2. Now let's approximate it. What the hell would that be? That is not very obvious to anyone who would read this, so let's erase that properly and rewrite it. 2.2 blah blah blah, and theta, I think that's what it's called. 63.4 blah blah blah. And always put a semicolon at the end of a line, especially in things like JavaScript. So let's go on here and hopefully get it correct. Well, use the correct conversion thing. So the first number is 1, so that goes into A. Second one is 2. And I think it's second A. Yes. So that would be R equals 2.2 blah blah blah. So you switch between them by pressing those two keys. Theta, probably saying that wrong because I don't exactly know what the name of it is. 4 blah blah blah, and I'm not going to round properly and instead just truncate, because truncating is less thinking intensive than rounding, and I am lazy. So let's take a look at it. The operation input of two variables is performed by following: X or R by pressing A key and zooming in on the iPhone so that you can actually see stuff. Input of two variables is performed by setting X or R by pressing the A key, and Y or space by pressing B key. The operation result of X or R is obtained in the display register. Oh, there is a display register. Has display register. Might as well write that down. By pressing A key or and Y or blank. What? By pressing B key. So you have that. So if we take a look at that. Oh, I think I know what happened. Fonts. They probably typed this, and it's actually in here, but it won't display because fonts. Well, anyway, so how slightly sad. Not really, but you know. Imagine that would be like that. Oh, you. Oh, infix notation, you suck. Seriously, stuff like that gets confusing at times. And for the other one, x colon y equals. Arc. I think I see what happened here. Cos r and then sine theta. I think that's what that. Instead, it's just x equals r cos space comma y equals sine nothing. So that's not exactly clear. So yeah, that would be quite easy to this already has like a floating point Earth ALU in it. Has a floating point computation thingy in it, and has the trigonometry also in it, so that would be quite easy to do. So it's follow on our way on the crappy yellow brick road that's actually made out of fake gold because complex number mode. So instead of the line or the Tin Man, we have random areas of mathematics, which makes sense because we're looking at a calculator. So, with the imaginary numbers, you have the real part and your imaginary part, and you have that. Because but the thing is, this does have the facility to zoom. There we go. To calculate with imaginary numbers, although it's limited to only add, subtract, multiply, and dividing. There is no square rooting, which is kind of sad, but hey, whatever. So to add that, you first go into complex mode by pressing second right arrow key, which is actually backspace. So you take for the first thing, you take the real number, press A, the imaginary number, which in this case is 1, press B, your operator, in this case plus, the display goes back to 0, so we go to this one, in this case it's 69, nice, A, and then the imaginary part is negative 420, oh wait, and that's B equals 71 minus 419i. It's even though that is definitely correct, let's verify. So first we have to put in parentheses, cause fuck you and fixed notation sucks. And there we go. So that's nice. And so the way for complex mode, so we have let's do that. You know, I'm actually gonna pause and yeah. And that is done. Now, weirdly, in the day sheets, it does it weird. I don't know why. So adding and subtracting is quite simple. It's quite straightforward. You just, you just do that. Multiplying is a bit more complicated, but still decently simple. And Jesus fuck, dividing is quite complex compared to the others. Not too complex, because obviously it's able to do it. But, yeah, that looks like it was a bitch to code in. And now, ladies and gentlemen, we are at the Wizard of Oz. Now, if only it was Joseph Stalin, that would have been infinitely better, and I'm gonna... So, no, it's already zoomed out. So, the input range, nah, we don't want that. So, n x squared. These keys display the number of data sample, each sum total of x and sum total of x squared. Average is formatted not correctly. That is weird. The fuck happened there? Oof. Oh, I think I see what happened. So it's... So the way this works is fucking ingenious. This has no list for the stat. Instead, weird piece of dust. It doesn't focus. It just keeps tracks of these. The hell was that noise? Yeah, those registers. So when you actually add something to there, it updates these registers. So if we take a look at n equals 1, sigma x, well, sum of all the samples equals 6, and sigma sum squared equals 36. Now, you guys in the statistics field are know more than me on this. I fucking hate statistics. It's confusing. I like other parts of math, not statistics though. Statistics can go fuck off. Add another thing. So 6m plus equals 9m plus equals, I hope I did do that, n equals 2, sum equals 15, sum squared equals 117. So this, obviously, 6 squared equals 36. That's where this comes from. So what it does is, so for the sum, it just takes the value from the display register and adds it just directly from there. The squared part, it just takes the screen register but squares it. Ooh, amazing. In fact, let's check this and probably embarrass myself. 6 squared plus 9 squared. So 36 plus 81 equals 117. Okay, so that's quite straightforward. But we do have we have other things, like, if I can actually see it. Well, we can also, like, subtract stuff from the values by pressing second F. By pressing second F. M plus but we also have well, our average, our S, which is, oh yeah, standard deviation, and the weird O, the O with a weird haircut, which has a proper name, but I don't know what it is. Standard deviation of the population. So, the average equals, well, that, which equals our sum divided by n, which is quite straightforward. Standard deviation, so the way this works on this calculator, square root this. Reciprocal of that. This is honestly kind of confusing because it's not formatted correctly. I almost touched that to focus, but that wouldn't have worked because reasons. I think it's... Is that correct? Probably not, but let's go with it. And the deviation of population, as I like to call it, with a weird haircut, on this calculator is... looks like it's actually... that's much better, to lie down instead of sitting in a weird position. It looks like it does that register minus the sum squared divided by n over n. Hopefully that's correct, but it's probably not. So let's check it. What am I doing? Fucking what? So let's statistify that data. So let's enter stat 13 plus 69 plus 420 plus 1609 plus... Okay, so n equals 4. Sum equals 2111. Average equals 527.75. Sum squared thingy equals... oh, Jesus Christ, that's huge. 2770211. Standard deviation equals 742.99 blah blah blah. Population deviation thingy, well, with a haircut, 643.45 ... So yes. So let's put these, this to these. So our variables, n equals 4, sum equals 2111, and square sum thingy equals 2770211. Let's do the average. So X with a hat, not llamas with a hat, X's with a hat. It's a new film cow video series, people. It's letters with hats. So that is sum over number data, which is in this case 21111 over 4, which equals 527.75, and that checks out. Now, S, standard deviation, equals, well, the square thingy minus sum thingy squared divided by n over n reciprocal, and then squirt that whole damn thing, which would equal so that would equal 2770211 minus 2111 squared divided by n over n reciprocal squirt that. So that so this would be 2770211 minus, well, 2111 squared minus 4456321 divided by n, well, n being 4, so let's actually replace that instead of just having mystery numbers, because that would be a bit shit. So that be negatives 1686110 divided by 4, which would be negative 42157.5. Put that over 0.25. Equal negative 1686110 square root. Oh. I feel like that's not correct. Well, the regular thing with that would just be which is not even close. So what the fuck is it doing? Is it Is it doing... It's doing that. Let's check it. Yeah, no, let's, well, let's just move on. Yeah, that's confusing. So, O with a hat equals... Well, let's actually check it on this calculator. So, stat, 1 var, 13, 69, 420, 1609. My favorite number because it's a prime. And then data. No, that's not correct. Yep, that's correct. Oh, with that. Yep. Yeah, I don't really know what that is coming from. Gonna have to think about that. So, population deviation thingy is... Let me just lie down instead of sit down. Much better. Is sum squared, the sum of all the thingies squared minus sum squared divided by n over n, and then you squirt the whole damn thing. So that would be 2770211 minus b. Shit, it's gonna do the thing again, isn't it? Yeah, let me just pause. Okay, so I pulled him from Wikipedia, and that's from there. Now on the datasheet it looks like reciprocal, but on Wikipedia it's just -1. Also, there's some other differences. Yeah, I actually sat down for a bit and actually tried working it out I can't figure it out. But the calculator gets the correct answers, and that's what matters. So what else is there to show about this? Oh yeah, there's this go to this stat. You can like directly modify one of the registers. No, which one is it? I forget how to do it. It's times number then and then m plus equals x store into n, which when I first stumbled across that, I thought it was a weird bug or something. Maybe it is. Don't know. Don't really care. Yeah. It's just bizarre. Well, now in SAT mode, because we have keeping track of some variables, we need somewhere to put those. So, it uses some of these registers. So, while in this mode, parentheses don't work. Something that, so if we do something like 6 plus 3 multiplied by 4, it complains at us because it doesn't have enough space because it has to store things. Also, in this mode, you can't the stat doesn't touch the memory register, but in this mode you can't access it, so that's bizarre. Also, a similar thing goes for like complex mode. You can't do regular arithmetic in here. You can't. You can do it through like these routines, but not on your own because there's not enough registers. Is that all? There's also the manual. Let's take a look at the manual. Well, it looks different from the one that came with this one, so let's take a look with it. Maybe it's better than the new ones because I actually learned how to use these things from the goddamn datasheet, which is just great. Dear customer, thank you very much for purchasing our electronic calculator. To fully utilize its features, please read the datasheet because we can't make things make sense. And let's bloop. To help ensure its longevity, do not touch the inside of the calculator. Oh, I forgot. I didn't take this thing apart. Let's alright, let's toss that to the side and let's take this apart. I actually grabbed this magnet from this magnet was used for like keeping curtains up, but the curtains were being thrown away, so I snatched the magnet. It's a really nice magnet for like, especially for like holding screws, which is what I'm going to be using it for. Let's see the differences. Experience the best. Experience Windows XP. Oh, there's another scope. If we take this out of the way, so that we have slightly better contrast, maybe that's better. I don't know. It uses the full-sized one cells, and we will actually be taking this one apart too. So, to compare the differences and glorious stuff like that. Even though that one's been like modified because I do stuff like that, cause I am weird. Man, I wish I knew where my like Phillips version of the screwdriver is. Something kind of annoying about these cases is the screws get loose over time. I don't know if that's just because I take them apart, these things apart. Probably that, actually, now that I think about it. But like the screw stocks, they crack over time, and so the screws fall out. So these do sadly, they do fall apart over time. So you kind of have to deal with that. Unless maybe it's just because I take them apart. It's probably because I take them apart that I wouldn't be surprised. What's also interesting is the color for the grip thing that's used to hold the case, the cover on, has a lighter color to it. I don't know if that's because it's been sitting in the package. I really don't know. Doing what the manual telling me not to do. So that's interesting. I was expecting the blob to be there, but it's not. We also have a cardboard backing to give a backing, you know, like you do. Let's take a look at that key matrix. I can actually get this off. Sentry also does this with their 4-function calculator. New car smell. I smell a lot of things. Don't know why. Just do. On. So there's calculators. Take a look at that. I see. Why the hell do the... This is really dubious. Because these things are a bitch to put back on. And there are some numbers on the circuit board. So first off, the other thing is, the color of the IC package is different. It's actually black. This one, it's like green or something. There's also numbers on the circuit board. Let me write that down. So the numbers are YC, although that's not exactly a number, but YC6605/01. And then in smaller letters, there is JJ6249. And then what appears to be a date code, it says 08.05.17. Here you go. Well, that's unexpected. Yeah, it's bizarre. I was expecting different. I mean, it even looks slightly different from even just from the look peering in from the battery cover. So. Oh, and there's also grips for the little side grip thingies. That is very nice, actually. Which way did this go on? This way. Is this still gonna work? I'm hoping it will. Yep. It's fine. Okay, well. And that came off. That's just beautiful. Get back in there. Thank you. Dun 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 dun. Actually, I'm gonna shut up before I get like copyrighted. No, it's not rattling. This one rattles for some reason. Don't know why. I'm gonna pause. Now, quick side note. When you're putting screws back into like plastic, make sure to back it up slightly till you feel a click. Back it up, Squidward. Wait, no. And then screw it in. That's to help use the original thread and not just create tons of new ones and then chew up the plastic. Alright, he's back together. Let's take this one apart. Oh god, oh god, oh god, it looks like this is leaked. Xavier, no, you're not ruining this. Well, that was dubious. Now, first off, ignore this and this, please. And this shiny, this is a piece of plastic. Well, first off, the die is in a green package, and it's on this side. Also, the placement of the ribbons are different. And this only had one battery, but because of weird stuff, I added two. And there's no backing. It actually. Is this what the rattling came from? Wait. No, it's not. There's no backing, so yeah, that's interesting. And the numbers on this is GX6610/201. Is there anything else? No. Yeah, I think that's it. This piece of plastic was actually making that noise. Well, there we go. Mystery solved.